Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem 33, Search and Rotated Sorted Array. This is a classic medium-level problem that often pops up in coding interviews, so mastering it is a huge advantage. The problem statement is as follows. We're given a sorted array that's been rotated at some unknown pivot point. Our task is to efficiently determine if a target number exists within this rotated array. We need to return the index of the target if found, otherwise we return -1. This sounds pretty straightforward, but the challenge lies in finding an efficient solution. We'll explore different approaches, and by the end of this video, you'll have a clear understanding of the most optimal way to solve this. Let's dive in. Understanding with examples. Let's solidify our understanding with some examples. Imagine we have the array 4, 5, 6, 7, 0, 1, 2. This is a sorted array that's been rotated. Now, let's say our target is 0. Can you spot where it is? It's at index 4. Another example. If the array was 1, 3, 5, 7, 9, which is already sorted, and the target is 3, we know the index of target is 1. But what if the array is rotated? Let's consider 9, 1, 3, 5, 7, and the target is 3. Notice how it's still in the array, but the initial sorted order is broken due to the rotation. Now that's the crux of the problem. A naive approach might be to linearly scan the array, but we can do much better. We'll look at efficient techniques shortly. Brute force approach. The simplest approach is a brute force linear search. We could iterate through the entire array, comparing each element to our target. If we find a match, we return its index, otherwise we return -1. It's straightforward to implement, but the time complexity would be O of n, which is linear. This isn't ideal for larger arrays. While simple to understand, this linear search would be too slow for many interview scenarios and real-world applications. So we need something more efficient, something that can handle larger data sets without significant performance hits. What other strategies could we explore to solve this problem? Optimal solution. The optimal approach leverages the fact that even though the array is rotated, it's still partially sorted. We can use a modified binary search to efficiently find our target. We'll start by comparing the middle element with the target. If they're equal, we're done. If not, we need to determine which half of the array is still sorted. Based on that, we'll recursively search only the sorted half, effectively eliminating a significant portion of the array with each step. This significantly speeds up the search process. The key is identifying which half is sorted to make an informed decision. This is the core idea behind this clever solution. Code implementation. Let's see the code in Python. We'll implement our modified binary search. We'll start with our function search that takes the array, nums, and the target as input. We'll then define the left and right pointers and enter a while loop that continues until our left pointer surpasses the right pointer. Inside the loop, we calculate the middle index. We then compare the elements at the middle index to the target. If they match, we found it. Otherwise, we check if the left half is sorted. If it is, we check if the target is within the left half. If yes, we move our right pointer. Otherwise, we move our left pointer. Otherwise, we're in the scenario where the right half is sorted, and we perform a similar check. This is the essence of the modified binary search technique. This will give us a much better time complexity as compared to the brute force approach. Time and space complexity. The time complexity of our modified binary search is O of log n, logarithmic time. This is a significant improvement over the linear O of n complexity of the brute force method. This means the search time grows proportionally to the logarithm of the input size, making it highly efficient for larger arrays. The space complexity is O of 1, constant space, because we're only using a few variables to track pointers and indices. We don't create any large auxiliary data structures. So, both time and space-wise, this approach is far superior for this problem. Engagement break. So, there you have it, a complete walkthrough of LeetCode problem 33. Before we wrap up, don't forget to hit that like button if you found this helpful and subscribe to the channel for more coding tutorials like this. And let me know in the comments what other LeetCode problems you'd like to see covered. Your support keeps these videos coming. I look forward to your questions and feedback. Let's keep this learning journey going. Conclusion. In this video, we successfully solved LeetCode problem 33, search in rotated sorted array, using a modified binary search algorithm. We started by understanding the problem, then explored a naive approach before implementing the efficient, optimal solution in Python. We analyzed the time and space complexities of both approaches, highlighting the significant performance gain achieved with the optimal approach. This problem is excellent for honing your problem-solving skills and understanding binary search. Remember to practice regularly and tackle similar problems to deepen your understanding. Don't forget to like and subscribe.